Okay.
Forgive me for I had 27 windows open, stepped away, and then it took me that long to unmute and find the window. So hello, everyone, and also welcome. This is Professor Gates. I also teach this course, and I am now here, and I can see your screen, so thank you for that.
Thank you very much. Okay, welcome everyone. This is an introduction to Data 630 course overview about the content as well as the structure of the course, and we will have a session to discuss them. You might have questions, general questions. My guess is at this point you don't have full understanding about the what the course is beyond what you've seen in the syllabus, but we will get a chance to explain some of the expectation in the course. So my understanding is there are two sections this semester, and I teach I'm for the BIOT 9040, and Dr. Gates teach the other section, which is 9041, and we have the same TA for both sections. Nivedita Vigilani is a TA. She's superb, and I believe we have a slide talking about the role that she plays in this effort. So, we gotta figure out how to advance. Just give me a second. There we go. So these are the discussion points, agenda for tonight. Some introduction about the course, outline of the course, like the structure, as well as some of the content that we will cover in the course, and some of the grading expectation, and how you will be able to achieve earning good grades. Some miscellaneous item like how to become successful in the course, given that a lot of content. And towards the end of the discussion, we will have a Q&A session for you to ask questions. My expectation, my experience is it should not run, we should be able to wrap up within between 45 minutes and 50 minutes, but it could go to an hour, depending on, your level of involvement. So for a few years now, the university doesn't require textbooks, so what they call open educational resources, so which means no textbooks for this particular course. But in general, if you want to pursue a career in data science, you would have to invest in resources, reading materials. But for this course, you are not required to purchase textbooks. We will provide all the resources in the course page, outside resources, links, books, reading materials, and video lectures. So updated additional links and articles will appear as necessary. So there are sometimes, as we go through the course, if there are some relevant material related to the content for that module, we might include those new sections. But for the most part, the main content is not going to change throughout the weeks, throughout the modules. So this is roughly the placement of the course. So our expectation is by now you would have gone through data 610 and 620, so you have a bit of understanding about pre-processing, how to do some exploratory analysis. In 630, so as you see, it's pretty much in the middle of the whole MS data analytics program, where you get to be exposed to modeling, like machine learning, kind of take it to the next level. You pre-process data, but also you explain the variation in the data, and if there is any particular question through modeling by fitting different kind of the algorithms. So we will cover it throughout the module, different algorithms. So this is a machine learning course, and you get exposed to the fundamental topics of machine learning, which will be followed by content advanced topics that you will learn in Data 640. Some of the topics that we cover here will be presented in advanced fashion in 640. And of course, at some point, you go to a little bit of prescriptive, and there's some gray area, what prescriptive means. But in general, when you go from the left to the right, it gets more challenging. So that is, the relative placement of the course in the whole program. I mean, it is very important course because you will, I believe this is formally when you start actually doing modeling and statistical learning, machine learning type of effort. And the bullet there says focus on techniques. So so we focus toward this implementation as opposed to underlying theory. I guess another way of learning this is focusing on the underlying logic, the mathematical underpinnings of each of the algorithms we cover. But in this course, the focus is mainly on implementation. So you get to expose to how you do each of the algorithms that we cover and actually implement in R and interpret the result and make understanding and adjustments to the models. So it focuses on the implementation aspect, not so much on the theory. It's important at some point you would have to see good progress in the field. Maybe when you become a senior data scientist, you'll have to deal with the underlying logic. But in this course, the focus is on implementation. So these are the main areas that we cover throughout the modules. So we have 7 modules in the course, and each of the modules have 2 weeks, except module 2, which is association mining, and the last module with, on group assignments. The group assignments are a little different. You start working on milestones starting week 4. In week 3 or 4 you will start forming groups. So except that, the rest have, like I said, 2 weeks for each module. So this module now that we are in, which is module 1, has data prep and visualization. This is how to load data in R. So this is the basics, For some of you who have never dealt with R, this is a week that you get familiar with the environment, some of the basic syntax in R, how to load data, do some exploration and visualization. So this is what we will cover in the next 2 weeks. In the following module, in association rules mining, a type of unsupervised learning that is based on discovering associations, rules generation process. We have only one week for that module. That's the exception. And when we go to the 3rd module, we will cover statistical data mining, or a classical technique like linear regression, logistic regression, and Bayesian classification. So the exercise is on linear regression and logistic regression, covers the assignments. You have to do the. Now this is just to give you an exposure to both methods. You have an option to do the assignment on Bayesian classification as well. So in subsequent slides, I will talk about what the assignment looks like, what the exercise looks like, what the difference between the two, and some of the expectations. And we move on to supervised classification. One of the supervised classification that we will cover in the course, which is decision tree, that is in module 4. So we will cover decision tree. We will also talk about classification, the principle of classification, how you evaluate classification models, some of their performance metrics and classification. So this is the kind of things that we will cover in module 4. Again, 2 weeks. And then we move on to another type of classification called neural networks. And we will spend another 2 weeks discussing about neural networks. And then in module 6, which is formally the end of the content that we'll cover, which is unsupervised supervised classification, very common unsupervised classification technique called cluster analysis, clustering, and how we do clustering. We focus on the k-means and the assignments and the exercise, but there are different kind of cluster analysis which we'll touch on. And the last week, module 7 has only 1 week, and and like I said earlier, by last module, you have already worked on milestones, so you're familiar, you have gotten feedback from the professors on your progress on the project. But that last week, there's no other assignments but for you to work on your final project and writing your report. Okay, so this is the overall structure of and the layout of the course. So this is more or less like the expectation. This is what the university calls competency-based course, which roughly means is you have to demonstrate your understanding. It's not necessarily by what you know, but what you show or demonstrate doing. So in the assignments, for instance, some of the expectation is sometimes this is not unique in academic environment, but in real world problems as well. You make any modeling, you make assumptions. So long as you make those, we explain those assumptions, and so this is where you really show your understanding and whether you understood the content or what is expected for that week. So you have to explain, you actually fit a model and explain the output, evaluate the model and performance and things like that. So we do have assignments for each main topic that we cover, as well as exercises. And like I said, I'll talk about the difference between the exercise and the assignments in the upcoming slide. And to the extent practical, we try to make the topic so that the content or the material we'll cover in the next week builds up what you learned in the previous week. So for instance, in supervised learning, we explain decision tree. Before we explain decision tree, we content the principle of classification, and that applies to other classification techniques like neural networks and others. So each subsequent module's content builds on what you learned in the previous. In R, in my at least experience, most students, by the time they come to 630, they're experiencing Python, but in 630 we use R pretty much exclusively. It says primarily here. So R is a platform. Python is a very good platform as well, and you can do pretty much what you can do in one and the other. So there's no really a winner, which one is. My personal experience is if you know both is good, but it's kind of difficult to be expert in both. The bottom line is we use R here. So for some of you, that might be a bit learning curve. So these 2 weeks, your opportunity to expose yourself enough to learn the R environment and the syntax. And obviously the discussions and the interaction. You are expected to interact, ask questions, provide feedback. In this being an online environment, that's the main channel that we use to, I guess, learn from each other. So that overall is what we call competency-based course. I kind of said this, we use R in our studio. R is a language and kind of a platform where, there are different packages to do any targeted stuff, any specific items. You load a particular package and So it's not just a language, it's a platform. And RStudio, I guess you can use R without RStudio, but that would be just not an optimal way to use it. RStudio is a development environment where it makes things easier to use R. Some of the regular chores, the routine stuff are simplified using RStudio. So R is in the background, the heavy lifting is done through R, but RStudio is a kind of user interface for you to interact with R. And so you want to use RStudio. And I think pretty much everyone that uses R uses RStudio. Tutorial for each module by the TAs. And now, sometimes the participation is not as great from students, but to the extent practical, sometimes we have live session on how to use R and relevant packages pertinent to that particular module's content. Okay. And I believe there is one coming up this week on introduction on R. If I haven't checked the web page, if the TA has already posted, but the point is we have tutorials either recorded or live on how to use R, from introduction to different packages relevant to the topic that we cover in the given module. And obviously, we have a lot of resources. I mean, there's a short list of resources for R. We also compiled a number of links and resources related to different topics that you can do in R. But like I said, you will find a lot of resources for learning R. So this is the grading distribution or the weights given to practice exercises and assignments. So obviously, each of the assignment will be on the topic that cover in that module. So for instance, assignment 1. Okay, so I have to say that I guess I have to explain that there is a bit mismatch. So we have 6 modules, but 5 assignments, which means we don't have an assignment for the first module. So instead, what we have is 2 exercises. So this is kind of an introduction for you. So I guess it makes sense for not dealing with an assignment for the first module. So you will learn the relevant material through exercises, practice exercise. So first week we have one exercise, and the second week of this module we have a second exercise. So there is no assignment. So assignment 1 will be on module 2, which is association rules mining, and that is 10% of the weight assigned to that assignment. And subsequently, assignment 2, we do the linear regression, the logistic regression and stuff on statistical classical techniques, and then there is an assignment 2, and then the associated weight is 10%. Similarly, we have assignment 3 for decision trees, assignment 4 for neural network, and assignment 5 for cluster analysis. And like I said before, there is a group project, which is 20% of the total grade. So you want to take that seriously from the beginning, which is from the way you form your group. I strongly suggest that we can always assign it randomly, but if you want to form your own group based on interest, that is always preferable. That's 20% weight. And each of the practice exercises worth 2 points, and that is, again, it would the syntax in how to do that specific. The algorithm is explained in the exercises, tutorial exercises, and you will have easier time working on the assignment if you did the practice. And I mean, to be honest with you, I don't feel like there should be grades assigned to the exercise because it's a tutorial. But nonetheless, we give you credit for going through the exercise. There are some questions just to make sure that you went through the exercise. But believe me, doing the exercise helps you finishing up the assignments. Okay. So total of 7 tutorial exercises. And this is another one, discussion items, like I tried to touch on this earlier, that this is an online environment. We communicate primarily through writing, so the discussion forums gives you opportunity to learn from each other. And then, so for each topic, we have discussion items, and there are words 2 points each, and you're required to post to make an initial post in the first week, and throughout the module, you have to also, you're expected to make response posts. And there are guidelines in the discussion forum itself, what the expectation, the content, and the due dates for each of those discussion posts. Again, this is to add interactivity, given that this channel that we're dealing with. I think I got kind of say that the third bullet: contribute interesting observations, questions, insights, experiences. And obviously will be tied to the topic that we'll be covering in that module. Grading, which is important, this being a graduate course, obviously the expectation is a bit higher. So if you do on time, on task, well written, complete, well explained report, that is what is the minimum expected in graduate class. That means B. So anything 80 to 85 B. So higher grades means if you want to earn A, you have to work a bit harder, right? So these are some ways that you can increase your grade or improve your grade depth, breadth in your explanation. Everything is open-ended, right? When you fit a model, so you should explain from the principle of that algorithm to the fitting intricacies, like the details of each parameters, the tuning, the performance of that model, and interpreting the result. All that required some depth and breadth of the discussion in the report. So yeah, be thorough in your discussion. In your discussion post, include alternative viewpoints and supporting viewpoint from additional sources. I mean, referencing is important. There is no one single place that you can get everything. So we rely on additional resources to supplement what we know. So that's important as well. And examples is really a really good way to explain what you're trying to communicate. And critical thinking. Again, like this is a graduate course, so adding content is the surest way to improve your answer. I don't expect, so the minimum required in the assignment is 7 to 10 pages. Obviously, I'm not expecting 50-page document, but if you provide a little more content, you're not going to get penalized for providing more. Okay, so long as it's cohesive and makes sense. Okay, so there's obviously then some of the ways that you can improve your grade, but there are different ways, not just length. The substance is what we're looking for. I guess this is an extension of the discussion we had from the previous page, some recommendation for success. So I guess you have to regularly, I think time management is a critical from my experience. I'm sure Professor Gates will have some, but my experience is if you well manage your time, because there is quite a bit of material in this course. This is a foundation course, so some of it are new for some of you. So manage your time, and that's key. And be on the course page regularly to see announcement and any new material that was posted by the professors. like I said, regularly read the announcement page. Questions, I know you will, throughout the course, you will, because this involves programming as well. And then, like I said, for some of you, R is new, so you will run into some issues. Try to spend some time before you ask questions. Uh, it's unavoidable. I deal with errors all the time, and you have to, try to debug your code before posting. But sometimes you get stuck, so at that point, you need to ask questions. And there are two question forums. One is for the professor, one is for the TA. The TA forum is primarily for programmatic issues like syntax errors, and sometimes, can get hard to run. Maybe, some dependency is not running. So when you're stuck, post it. Please don't use email for that kind of stuff. Please use because somebody else likely will have the same problem. So for the benefit of others, post questions at TA forum related to software programming and how related. Concept related, use a professor like logic and understanding the concept that goes into the professor's forum.
Dr. Bhatia, I think I'll go ahead and make a quick addition here and see if there are any questions for me as well. This is Professor Gates. That was a wonderful overview, and so I won't repeat any of the information that Dr. Bhatia has shared with everyone. What I will add is just a little bit of information about R programming, just so that for those of you who are either new to programming or new to R programming specifically, you have an idea of what you're coming into, because expectations really can be managed if you know that something may be challenging, you can set aside extra time and so on. So it is not uncommon for our students to not have R programming experience, maybe also some limited experience. It really depends on what background you come from. The other side of that, though, is that if you are new to programming in R, R is a quirky language, and it takes some getting used to. I would like to encourage everyone very, very strongly to debug your own code. Code error checking and debugging and the way that you program is arguably 70% of coding. So if you run into a bug and someone else fixes it for you, they're essentially doing 70% of the work. And that's a very good way to think about it, because it's not only true, but when you're out there in industry, you're always going to be confronted with new things. And no matter how good of a programmer you are, and I think Dr. Bhatia could also agree with this, you're always going to run into bugs, always. And usually, if, for example, if you're programming a new method that you haven't programmed before, you're trying to code a support vector machine, or you're trying to code association rule mining, that's just not going to be easy the first time you do it. And so I would suggest that you avoid that knee-jerk reaction of spending 45 minutes and feeling like that was a long time. Time management in a class like this can be challenging because we all have a million things going on. A lot of us have families and full-time jobs, but at the same time, it's important to recognize that you will need to spend the time, especially if you don't know how to code in R, because you will have to learn to code in R. And the truth is, the only way to really learn is to kind of suffer through learning how to learn to code in R. When you run into a bug, your knee-jerk reaction should be to get on Google and find a solution. That should always be your initial reaction. Usually, you're going to look for a solution for hours before you might finally give up and post it for the TA to see if someone's had a similar issue. So that's just something to keep in the back of your mind. If you're coding and you're running into problems, what I also recommend is back up. In other words, comment out information until you get to the point where your program does run. And then add back your code one line at a time so that it's easier for you to identify where's the error, what line of code is giving you trouble. The other thing about R that's fabulous is that there's usually 50 different ways to do the same thing. So if for some reason you just can't get it to do what you want it to do, try a different way. Then finally, I'll note that there are probably 1,000 R books online that are free. And one of the areas of R is called Tidyverse. Tidyverse is becoming more and more popular. So if you want to kind of investigate that while you're learning your R, I would recommend that. And there are many free books for that as well. So just wanted to put that information out there so that you know what's coming and you know that coding in R is going to be frustrating so that you don't feel like it's just you or you're alone in this. It's true for everybody. And that's all I really need to add. I think Dr. Batty covered everything else, and we're both open for questions, but I'm going to go on mute and hand the microphone back.
Okay, thank you. That was really useful. Thanks for that comment. So another communication channel is sometimes, there are issues of personal in nature, like, sometimes you can't make it to deadline and there are personal issues that you need to communicate with the professor. Please use email for that. And the expectation from the university is we will try our best to respond within 24 hours. Okay, we check our emails regularly. And also, anything related to grading and things like that. Okay, so this is not, this slide is not unique to this course, but in general, in data science, to be successful in this field, kind of unique field where you have to have a working knowledge in multiple domains, computer science, primarily for the programming aspect. Although there are, packages, ready-made packages these days that you can use for performing analysis and even fitting machine learning models. But at some point in your career, you would have to do some programming. Really, there's no shortcut to that. That makes you very powerful. You can do prototypes. You can, reuse other codes, existing code, somebody that developed that skills, computer science. It goes beyond that, but at least the programming aspect is important. So that is one pillar of this Venn diagram. There's many versions of this diagram, but really the core is the three domains. And the other one is the mathematics. Earlier I said that we don't spend a lot of time learning about the underlying logic. But again, as you progress in your career, you would have to deal with that at some point where you need to debug. It's rarely required, this aspect, because most of what we do is we use existing packages somebody developed for certain years, and then we use multiple packages in our modeling exercise. But understanding the low-level stuff helps in tuning the parameters because you have to understand what combination of parameters work better, if you have good knowledge or good understanding about the underlying implementation. So the mathematics is also kind of important for data scientists. Another is domain expertise, which is to say that data science is not done in a vacuum. Obviously, you have to solve a problem in a given domain, and most likely in most domains that you would have to work experts from that domain. So you are expected to have a working knowledge to be able to communicate with experts in that field. Both to explain the output of your model as well as to understand and define the problem the way they explain it. So that is also another important element. If you happen to have a very good understanding about the domain, your data science effort becomes a little manageable, easier. Okay, that's what separates data science from being a classical statistician. It's not, you're not just crunching a number. You want to have good understanding about the working domain. You're not just a mathematician, but somebody who can crunch a number, but also apply that logic to a real scenario. And sometimes make an assumption, and those assumptions help you explain some of the things that, well, as an example of that would be, let's say a model tells you something, But if you don't, sometimes that output, although it may be a statistically significant observation, it could be explained, or it may be explained by operational parameters, right? So that is, we will discuss this kind of stuff when we cover, when we discuss learn some of this learning algorithms throughout the module. So, like I said, this is not unique to this course, but throughout your career in data science, try to apply this. But the key, at least for this course, is the programmatic aspect. Like Dr. Gates said earlier, spend enough time to learn R. It will help you. So that is the end of this discussion, and I will open up it for questions and any discussion, comments you might have. I know I mute you all, so if you have questions, just go ahead and mute yourself and speak up. And I believe we have, we are 40 minutes into the hour, so we have some time to have a discussion. If you have any questions, suggestions, like I said, anything that's not clear about any part of the thing that I said. Okay? Any questions? Any comments? Nothing unclear? Or is everything I said?
Yeah, this is Pradeep Tyagi. Can you hear me?
Yes, I can, Pradeep.
Okay. So this is Pradeep Tyagi. I have a question for Dr. Gates. Dr. Gates was mentioning about tidy, and she used some other word, tidy, something that you need to go there and check it out. What was that website? Was it a website name? I didn't hear it completely.
Okay, the package name is Tidyverse.
Tidyverse.
Verse. And if you just Google it, it will lead you to the documentation.
Tidyverse.
I don't think we will cover it in the course, but it is literally impossible to explain anything. We only expect you to deal with packages that are required. Now Tidyverse is becoming popular, although it's not required for the things that we cover in this assignment. So Tidyverse is a package name. Everything is R is a package. So, and if you have any specific questions about, what her suggestion was, are you in her class?
Yes, sir, I'm in.
Okay.
Yes.
So you might pose that question to her if there's any specific thing that you want to.
No, there was no. I got the first word, the
tidy.
I didn't get the last one, the verse. Yeah, so Tidyverse. I took a note. Thank you.
All right.
Hi, this is Nick. I was wondering for exercises, do you want us to submit the scripts in .r files, or do you want it in like a different version, like Notepad++?
No, everything should be in R. You got to get used to the habit of. It's not that difficult to convert. It's interpreted language. R is, you can save it in.
Yeah, I just wanted to make sure when we.
Okay. Yeah, R is preferable because we don't have to make any changes. If the TA or myself want to run it, I can easily run it. So please save it as R. And by the way, you don't have to do anything. If you save it within R Studio, by default, it goes to that R extension. Any other question? Okay, that's fine. I'm sure you'll have questions. That's why we have the discussion, the question form in the class. Anything that's not clear here? Obviously, there are a lot of things that we haven't covered. This is an introduction, obviously. But now, really, the point that I want to stress is This is not to scare you, but there's a lot of material, so time management is critical. Every module, you have to do the reading, you have to do the exercise, and then you have to do the assignments. Okay, so but this is a graduate course, so the expectation is, I mean, you can imagine 10 pages for each module. You have to write assignments on top of, providing the discussion and, participating in making response posters and also working on the exercise. And then starting week 4, you also be doing the group assignments, which is 20% of the total grade. So time management is key, and I'm usually checking the class forums regularly. I interject and I participate in the discussion myself. And so, although it's a lot of stuff, a lot of material, but I think this is a foundational course, so it's critical that you learn all this material, because machine learning has a lot of things. It's nearly impossible to cover everything, but the basics we have to cover it, and then that you'll be better off when you go to data 640, when you exposed to advanced application of some of the algorithms like deep neural networks and ensemble methods. So what you learn here becomes important. That's all I have. If you guys don't have any other question, I will wrap this up. And I recorded this, so for those of you who want to, I guess, listen again, or for those who are not able to attend, there's an opportunity for them to replay. Okay? And thanks for your participation, and you have a good night, and I'll see you in class.